Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. But before I get started, I want to say I hope that everyone is doing all right out there. I'm not sure how I'm going to title this. I'll tell you when I tell it in the title. But what I am sure of are our 3 goals for today. Our first goal is going to be to review the Triangle Sum Theorem. Our second goal is going to be to use the Triangle Sum Theorem to find the sum of the interior angles of a quadrilateral, pentagon, hexagon, etc., etc. 4-sided shape, 5-sided shape, 6-sided shape, etc., etc. And our third and final goal is going to be to investigate the property of an exterior angle of a triangle. Alright, so let's just jump right into our first goal here. We have already seen that the 3 angles of a triangle add to 180 degrees. This was needed earlier to show what perpendicular slopes must be and to help us understand why the angle side congruent triangle criteria works. Let me just hit the brakes here real quick on the lesson. One of the things that I didn't understand when I was younger was why teachers bounce around in the order of the book. And as I've taught, I realized they do it so that they can make more of a continuous story of the mathematical concepts. So if I bounce around and tell you, oh, this thing, and then this idea, and then this idea, and it's like a Quentin Tarantino movie, you're not really going to see how the concept develops organically. And so since I want to try and make this as smooth as a transition from one idea to the other, I needed to talk about what the 3 angles of a triangle added up to before the book actually introduces it. So there is a lesson. You can go back and watch the how it was created. I think it's like a 7-minute lesson, and it was maybe I forget the title. I'll see if I can figure out a link to how to link to it in the title. I probably won't though. But anyways, let's move forward now. Okay, so let's review the Triangle Sum Theorem, and it's the 3 angles of any triangle add to 180 degrees. So whenever you see a triangle, you know this, okay? And it's a potential first step. So we know when we see this triangle, we know that the measure of angle A plus the measure of angle B plus the measure of angle C, those add up to 180 degrees. Now, when I introduce this lesson in person, they add up to 180 degrees. What I do to my class is we try and draw the largest triangle we can on a piece of paper with a ruler, and they're all different. And then we cut them out, and we show off our triangles to the class. And I walk up and down the rows, and I look for the nicest looking triangle. Once everyone agrees this is the nicest looking triangle, what I end up doing is I end up ripping the angles off of it. And everyone's shocked that I do this, but there's a reason why. And if I was to rip the 3 angles off of this, we would actually see that angle A, right? There's angle A, and then we would see that angle B, and then angle C. Those would actually add up to 180 degrees. So if you want to see this for yourself, cut out a triangle, rip off the angles, and then line them up, and you'll see that they do add to 180 degrees. We can physically see this, but we've also already argued it. All right, so I'm going to go ahead and check off the first goal. We're going to review the Triangle Sum Theorem. I'm done with that. Let's move on to the second goal, and that's going to be to use the Triangle Sum Theorem to find the sum of the interior angles of a quadrilateral, pentagon, hexagon, 4-sided shape, 5-sided shape, etc., etc. Alright, so into our second goal. We can use the Triangle Sum Theorem to find what the sum of the interior angles add up to for a 4-sided shape, which is a quadrilateral, a 5-sided shape, which is a pentagon, and so on. We can establish a pattern and extend the observation to n-sided and create a formula to determine the angle sum for any shape. We're not using x, we're using n. And that's a reference to what's called a natural number, and the natural numbers are the natural counting numbers: 1, 2, 3, 4, 5, 6, etc. So, and when we say n-sided, it has to be 3 or more, okay? Because otherwise, there's no interior angles on a 2-sided shape. right? So, well, actually, there's technically one, I guess. So let me go ahead and clean this up, come back and get into the second goal with a little bit more detail, and hopefully we can establish from a pattern what the interior angles of any n-sided shape must add up to using what we know about the three angles of a triangle. So let me clean this up and I'll be back. I'm back. So let's go ahead and continue with our second goal, which is to use the triangle sum theorem to find the sum of the interior angles of a quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, 11gon, 12gon, 13gon. I don't remember all of the names. But basically, 4-sided shapes, 5-sided shapes, 6-sided shapes, etc., etc., etc. All right, so let's continue with this second goal. The rules to properly determine the sum of the interior angles of n-sided shapes. First, triangles can be created from only one vertex. Vertex is a very fancy way to say angle, and triangles will be created using diagonals. These are segments that connect non-adjacent vertices. If they connected adjacent vertices, adjacent angles, that's just the side. So you would actually have to have a non-adjacent. So diagonals actually go through the interior of the shape. The second thing that we need to know for our rules is every triangle created adds 180 degrees to the angle sum. All right, so I have 4 shapes. One's 3-sided, one's 4-sided, one's 5-sided, and one's 6-sided. And I have a table that's going to help us organize what we discover. And like before, it's a little bit better not to put numbers together. So I don't know if you remember, way back in the beginning of this class, we actually learn more by not putting numbers together. We establish patterns that way, and then once we recognize a pattern, we extend that to x prior, but for this one, we're going to extend it to n, because remember, n is a way to represent a natural number, and natural numbers are the counting numbers, the ones that naturally occur to us, 1, 2, 3, 4, 5, etc. Even though there's numbers that naturally occur that aren't natural numbers. Anyways, back to this. Okay, so let's look at our 3-sided shape. The number of sides, it has 3. And I cannot connect this vertice to any non-adjacent vertice. So that means that I have one triangle. And since I have one triangle, that means that my angle sum has to be 180 degrees. Okay, let's look at our 4-sided shape. We'll start at this vertex. I can't connect to that because that's adjacent. I can connect to that because that's non-adjacent. I can't connect to that because that's adjacent. So we actually have established 2 triangles. And 2 triangles means that I have to add 180 degrees to the angle sum twice. So this is 2 times 180 degrees. So that means that 4-sided shapes, the interior angles must add up to 360 degrees. It must. All right, let's look at our 5-sided shape. I'm going to start at this vertex. I can't connect to that because that's adjacent. I can connect to this because it's non-adjacent. I can connect to this because it's non-adjacent. I can't connect to that because that's adjacent. On a 5-sided shape, I get 1, 2, 3 triangles. And remember, each triangle created adds 180 degrees to the angle sum. So that means that I have 3 times 180 degrees, which means the 5 angles of any 5-sided shape must add up to 540 degrees. Let's look at our 6-sided shape. Let's look at our 6-sided shape. I'll start from this vertex. I can't connect to that because that's adjacent. I can connect to that because it's non-adjacent. I can connect to that because that's non-adjacent. I can connect to that because it's non-adjacent. Can't connect to that because that's adjacent. My 6-sided shape creates 4 triangles on the inside. All right, and that means that the 6 angles must add up to 180 degrees 4 times, right? Because the number of triangles created represents 100, or every triangle created adds 180 degrees to the angle sum. So I have 4 triangles at 180 degrees each. So that means that we have 720 degrees of angle measures in 6-sided shapes. All right. So I think we have a pattern. There's a pattern between these numbers. Okay. So an n-sided shape is going to have n minus 2 triangles, right? Because we always have 2 less than the number of sides. And that means that the angle sum is going to equal to the number of triangles times 180 degrees. All right, so hopefully you understand how we got to this result. I'm going to erase all this, come back, show you the formula that we can get, talk about the 2 types of possible questions that can come from it, and I'm going to start our third goal here. So let me clean all this up and I'll be back. I'm back, so let's continue with this second goal here, and we're going to now create our formula for this with the interior angles add up to for an n-sided shape. So remember, n is the number of sides, n minus 2 is the number of triangles, n minus 2 times 180 is the angle sum for an n-sided shape, or we can make it more of an equation by saying n minus 2 times 180 equals the sum of the interior angles. Again, n minus 2, so the number of triangles times 180 is what the interior angles add up to. Okay, so this equation actually has 2 unknowns. It has n, which is the number of sides, that's one unknown, and the other is the sum of the interior angles. You will be given one of them, these are trying to say them at the same time. You'll be given one of them and you will need to solve for the other one. We solved using our 6 steps from earlier in the year. So this first example, find the sum of the interior angles for a 10-sided shape. Do I have the number of sides, or do I have the sum of the interior angles? I have the number of sides, so I'm just going to plug in here. So I have this formula where n is now 10, so it's 10 minus 2, and that's times 180, and that equals the sum of the interior angles. N minus 2 becomes 8. 8 times 180, let's see here. 8 times 100 is 800. 8 times 80 is 640. So that becomes 1,440 degrees. So that's 1,440 degrees is equal to the sum of the interior angles of the 10-sided shape. I thought that if I picked 10, I would multiply 10 times 180 and get an easy result, but I overlooked the fact that I take away 2 from it. So is the sum of the interior angles of a 10-sided shape. So that's working out an example where this is known and that's the unknown. Let's flip it and let's start off with this being known and that being unknown. How many sides does a shape have if the interior angles add to 180 degrees? I know this. So we have n minus 2 times 180 is equal to 900 degrees. Okay. So our 6 steps. Can I eliminate a fraction? No, but I can distribute. This is going to bother some of you, but you can distribute from the right. So now I get 180 n minus 360, and that's equal to 900. Can I combine like terms? Nope. Are all my n's on one side, so I can't do that. Can I add or subtract away a number from the variable side? Yes, I can. So 180n is equal to 1260. Okay. Can I divide away a number with a variable? Yep, I can divide away the 180. And so let's see here. 180 goes into, well, I know that 8 times 180 is 1440. I think that might be 7, right? So 7, yeah. 7 times 100 is 700. 7 times 80 is 560. So that means that this shape has 7 sides. A 7-sided shape, the interior angles add to 180 degrees. Now, there's one more wrinkle. One more wrinkle on this problem, and I think I have enough space to finish it. And that's going to be if you see the word regular. And when you see the word regular, it's a real fancy way to say all angles are the same size. Okay? All angles are equal. All angles and sides are equal. All angles are, let me say it again. All angles are congruent. All angles are congruent / equal, and all sides are congruent / equal. So you might be asked to find what each angle measures in a regular shape. And so if we were told that the shape was regular and the interior angles added to 900, then you know that each angle has to be equal. And so in order to answer this question, what does each angle measure in the shape? In a regular 7-sided shape, divide the 900 by 7, oh my gosh, okay, let's see here, that goes in twice, so let's see here, that goes in twice, so that's 2, no, it goes in once, so it goes 1, and then I have a remainder of 2, and that's 20, so then that's 2 for 14, that gives me a remainder, so 127, so 56, 107.5, 35, 40. I think that's just going to repeat. Oh, 5, 7, something. Right. So that's what each angle will measure in a 7-sided regular shape when we know that the 7 angles add to 900 degrees. All right. So hopefully this makes sense on the formula, how to use the formula with the 2 possibilities. And regular is a real fancy way to say, hey, now all the angles are the same. So be aware of that. I think this covers everything for our second goal. And so let me come back and talk about the third goal and wrap this lesson up. So I will be back. I'm back for the last time, I promise. All right, so let's go ahead and go into our third goal, and it's going to be to investigate the property of an exterior angle of a triangle. So an exterior angle is created by extending a side length. So if we start off with this triangle, and I decide to extend this side right here, I get this picture. Now, when I get this picture, we created a linear pair. This is a linear pair, which adds to 180 degrees. By the way, the 3 angles of a triangle also add to 180 degrees. Do you see how I'm setting up the transitive property? It's coming up. So if we label the angles, we get angle 1, 2, 3, and angle 4. Angle 4 is our exterior angle. We can write the following equations. I can say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. Those add to 180 degrees. I can also say that the measure of angle 1 plus the measure of angle 4 add to 180 degrees. The first reason why is because the three angles of a triangle, right? The second one is because I have a linear pair. Well, if two things are equal to the same thing, then those two things themselves must be equal. So now I can say that by the transitive property, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals the measure of angle 1 plus the measure of angle 4. So this is here and that is there. These two things are equal. And guess what? They both have a measure of angle 1. So let's get that out of the equation. And so now what we know is the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 4. Okay? So basically, we have an idea here. This is called the Exterior Angle Theorem. It's a horrible X. But most of them are. Exterior Angle Theorem. Okay. That's a bad M. There you go. Okay, they're not horrible. So let's see here. So basically, if I have an X and a Y and a Z, I know that the measure of X degrees plus the measure of Y degrees equals the measure of Z degrees. Oh, you know what? I'm not doing this because we just had a discussion about this, and I understand the C. We'll say, gosh, I'll go back to 1, 2, and 3. So we know the measure of angle 1 plus the measure of angle 2, that has to equal the measure of angle 3. All right. So you're going to be asked to probably use this in the book homework. Hopefully you understand where it came from. I think it's a pretty easy formula to create from our experience of the transitive and getting things to come together. So I'm going to go ahead and end it here. I think I'm happy where we ended up. We should have enough tools to answer all the questions for this section. Remember what the Triangle Sum Theorem is and how we use it to find the sum of the interior angles of 4-sided, 5-sided, 6-sided shapes. How we created a formula and how that formula has two unknowns and we'll be given one and we use it to find the other. Understand how the concept of regular ties into the problem. And finally, what an exterior angle is equal to inside of the triangle. It's equal to two non-adjacent interior angles, the sum of the two non-interior adjacent angles. All right, so I'm going to go ahead and end it here. I keep saying that, I should probably do it. Again, I hope everyone's doing all right out there. Have a great day, everybody. Bye-bye.